Maritime autonomous surface ships, or MAS, are currently being trialled at sea and are likely to be introduced conventionally very soon. Looking at the Lloyd's Register, there are different levels of shipping autonomy, from level 0, where there is no autonomous function, to level 3, where there is an active human in the loop, up until level 6, where the ship is fully autonomous with unsupervised operation. There appears to be significant attempts to look at regulations for MAS, but according to Channon, there appears to be some difficulty. The existing shipping regulations that we have, if applicable to MAS, may prove to become significant barriers to the widespread use. This includes the United Nations Convention on the Law of the Sea of 1982, or UNCLOS, then the International Convention for Safety of Life at Sea of 1974, or SOLAS, and more.
The first thing to discuss is the United Nations Convention on the Law of the Sea, 1982, or the UNCLOS. The UNCLOS is the main international legislation to regulate ship sailing in international waters, or the high seas. Article 94 of the Convention currently serves to regulate the masters and crews of the flag states. However, some of the language used in the provisions introduce significant barriers to the introduction of maritime autonomous surface ships. This is a particular problem for ships with a high level of shipping autonomy at levels 2 and above on the Lloyd's Register. It is unclear whether a MAS is defined as a ship, but if they were found to satisfy the requirements, Article 94 further introduces a range of other problems to overcome for autonomous shipping. In particular, Section 3, Provisions A and B of the Treaty both describe measures that the states are required to take in relation to ensuring safety on board their ships. This regulates the seaworthiness of a ship and the manning and training of the masters and crew. Firstly, it is important to discuss the notion of a master controlling an autonomous ship. The main issue here is that for ships with a high level of autonomy, it may not be necessary to have a master on board or even supervising an operation. The provision states that this is necessary to ensure safety at sea. However, it is evident that without a master or crew on board, autonomous ships may even result in the eradication of danger for a crew who would otherwise be exposed to such dangers when manning a ship. In addition, Section 3 introduces the question of whether someone controlling an autonomous ship from the shore can be considered a master. It is likely that this will be the case, as many of the technological duties associated with navigating a ship can be fulfilled remotely. However, it remains unclear as to whether this specific provision can be fulfilled for ships undertaking a fully autonomous and unsupervised operation. Another important barrier that Section 3 brings about for the introduction of MAS is whether an unmanned vessel can be determined to be seaworthy. Whether or not a MAS ship is determined to be seaworthy depends on how the word is interpreted. Is a ship seaworthy if it doesn't have a master on board? The interpretation of seaworthiness has changed over time and is largely found nowadays to relate to the technological, navigational systems and the physical condition of a ship. Therefore, this does not introduce a significant barrier to the introduction of MAS, as even a fully autonomous ship may be able to satisfy this requirement. Following on from Section 3, Section 4b of Article 94 reinforces the necessary measures relating to the safety of a manned ship sailing in international waters. Now, the language used here is much more explicit and describes a requirement to have a master and officers who possess appropriate qualifications and a crew that is appropriate in qualification and numbers to ensure safety. For ships operating at low levels of autonomy, the provisions can be fulfilled by having a master, officers and crew that are appropriately trained either on board the ship or supervising the ship from a distance. However, fully autonomous and rarely supervised ships do not seem to satisfy this requirement. It would seem that the possession of relevant qualifications will not affect the safety that a computer program may be able to ensure. In addition to this, the specification for a crew to be appropriate in numbers is not compatible with the introduction of MAS. It would seem that the language used in this provision may be too specific, and therefore will prove to be a significant barrier. In the future, it is possible that there may be different legislative interpretations that allow for Article 94 to be compatible with MAS. For example, it is entirely likely that a navigation program can be considered a master, as it may be in full control of the ship. However, in its entirety, Section 4b contains too many provisions that are on the surface incompatible with maritime autonomous surface ships. So, how significant are the barriers introduced by the UNCLOS to autonomous surface ships? Initially, it is important to analyse the provisions against the current climate of MAS, as it is likely that in the near future fully autonomous ships will be used for cargo and non-passenger purposes. Therefore, the safety measures set out in Article 94 may not always be relevant, as fully autonomous ships can ensure greater safety to human life. Also, it would seem that other safety measures are simply irrelevant when considering ships that have high levels of autonomy, particularly levels 5 and 6 on the Lloyd's Register. This includes the requirement to have a shipmaster or crew on board the vessel. Whilst it can be argued that the majority of the legislative language used in the UNCLOS can be interpreted to include aspects of manning an autonomous ship, for example, the necessity of having a seaworthy ship in Section 3A and the notions of a master in Section 3B. For fully autonomous ships, these regulations are extremely conflicting. Therefore, it is reasonable to conclude that the significance of the barriers that Article 94 introduced for mass are dependent on the level of autonomy of a vessel. Whilst it is likely that ships with a low-level autonomy may be compatible, fully autonomous ships do not satisfy these same requirements.
The International Maritime Organization has set out SOLAS, and this applies to ships. So if the mast falls under the flag state's definition of a ship, which is privy to the convention, the manning regulations will apply and could be a potential barrier. Regulation 14, Chapter 5 of the SOLAS states that contracting government administrations shall set out minimum safe manning requirements following a transparent procedure, considering relevant information provided by the organization, following which they will issue a safe manning document. SOLAS relies on the states to set out safe manning regulations on their ships, so if it is an autonomous ship, then would 0 people be adequate to keep it safe, keeping in mind the offshore assistance and high automation levels reduce onboard manning requirements? This question is posed by Veal, but it is important to keep in mind that if 0 people are on board, this would literally be an unmanned ship and does not satisfy the requirement if the standard definition is used. It makes more sense to interpret this in the first manner, as suggested by Veal and other academics, as administrations may permit unmanned ships themselves, much like how flag states already have a lot of control over definitions and safety credentials with respect to navigation, so it would be consistent. An issue with SOLAS is that associated guidelines of the regulation are more detailed than the regulation itself, but these are not legally binding, and this is what leads to the debate over manning and tending in the first place. As pointed out by Ringbaum, technical equipment and levels of automation are to be taken into consideration when deciding on manning levels. The purpose of these manning levels are for the safety of the ship and surroundings, so it could argue that operation of the ship might actually become safer if more functions are automated, because factors such as electronic lookouts may detect more than humans, and redundancy systems would be installed on board. So then would safe manning levels be 0, because the need for it is to be sufficient and efficient as well. Carey points out that subjective manning levels is what allows the UK to authorize safe manning levels of 0, depending on the level of automation of mass. But this is interesting because Singapore, for example, would need minimum of 2 people on board to be seaworthy. However, if an autonomous ship with no people from the UK was doing trade with Singapore, when they are in Singapore's territory, although they have a safe manning document from the UK, how would this play out? Because in Singapore, that would still be considered an illegal ship. When looking at commercial shipping mass, the context of SOLAS regulations in terms of what constitutes a shipmaster, the crew, and officers will have to be reviewed in terms of an unmanned shipping context. Another issue to do with unmanned shipping would be how different flag states could have different minimum manning requirements but still allow ships from other flag states into their territory. However, in the case of passenger-carrying mass ships, this would require an entire new concept of thinking related to processes of evacuating people on board and rescuing people from the water that cannot just be accommodated by amending existing instruments or applying equivalence. But this is not of pressing importance right now, as passenger-carrying mass ships are a thing of the future, and commercial mass would first have to be regulated well in an attempt to move on to passenger mass.
Finally, other regulations likely to provide a significant barrier to the introduction of mass include the STCW and Core Reg. So, firstly, Ringbum argues that Part 8 of the STCW represents the most direct legal hurdle for remote operations due to the officer's responsibility that a safe continuous watch be maintained on all ships at all times. However, unless a remote watch is allowed, this would unlikely be satisfied, hence constituting a barrier. This barrier increases in the case of a fully autonomous ship, or only if a virtual watch is allowed would the requirement be met. Furthermore, the requirement that the officers be physically present would be impossible for any MAS to satisfy, hence constituting another barrier. Part 4 of the code likewise stipulates a barrier with the requirement that at no time shall a bridge be left unattended. Clearly, no MAS would satisfy this because the whole point of the ship being autonomous is that it controls itself without the need to have a crew on board. It thus would not be attended and so would be in a constant state of unattended. Hence, this requirement would block MAS from being able to sail. On the other hand, the code may not be a barrier if, as Veal argues, it doesn't end up applying to MAS. This is because, as Article 3 states, the Convention applies to seafarers serving on board seagoing ships. This limits the extent to which a convention will be a barrier to MAS because it may not be applicable to them at all, since they won't have seafarers on board. Indeed, Veal argues that there is in fact no internationally uniform standard for the training and qualifications of shore-based personnel conducting UMV operations. A side note, there is at national level with Maritime UK Code of Practice. Anyway, if, as Veal argues, the convention does not apply to MAS, another barrier could nevertheless arise because states' tasks of fulfilling the Article 94 of UNCLOS obligation in respect of the training of shore-based crew will be much more difficult, hence becoming a barrier. This is because, with an absence of standardisation, training will be done on an ad hoc basis. This could mean that jurisdictions have different rules, and when ships meet on the sea, conflicting rules will mean problems, hence building a barrier for MAS. This is hence why the convention is likely to be applied to MAS, since they'll operate alongside conventional manned ships. The remote controllers will need to have knowledge of how manned crafts are operated and will require training at the very least to the extent of required for seafarers. In turn, the convention will likely apply. This, however, then brings us back to the barriers aforementioned. Lastly, there is core reg. The issues here arise inevitably with fully autonomous ships. Indeed, the collision avoidance rules under core reg presume that a human is in the decision-making loop and refers to the good seamanship of the master. Moreover, the decisions are not supposed to deviate from the ordinary practice of seamen. Clear issues arise here. Can a ship really practice good seamanship? To what standard would we place a fully autonomous ship at? To that of a perfect seaman or that of the average reasonable seaman? Indeed, one of the reasons that MAS has been introduced is because of the benefit of reduced human error. But what happens if there's a fault in the system or the ship comes across an issue that a human would know how to solve, but a ship wouldn't? Who's liable? Without answers, these questions arising from the requirements of the core reg pose clear barriers for MAS, simply because the requirements will require a human element, something which MAS simply will never be able to have. However, as Veal argued previously, this may not apply to MAS. Core reg likely would exclude most MAS because of the prerequisite that the regulations will apply to vessels capable of being used as a means of transportation on water. And for now, only the very largest of MAS have transportation credentials as conventionally understood. However, this is limited because MAS may still be considered to be a vessel for the purposes of the Act regardless. There is no international definition of ship, and so there is a chance that they may be considered by the court. In this case, there is no reason why Rule 2, that of the seamanship standard, would not be able to be exercised remotely or autonomously by the ship. Indeed, this would be a benefit as opposed to a barrier for MAS, as it would introduce a universal duty of good seamanship, the equivalent to that of a duty of care owed between the users of the sea. This is something which many jurisdictions don't have and would increase safety requirements for MAS, thus making routes and ships safer and in turn increase the trust in them. However, Rule 2 does present a clear barrier for fully autonomous ships using algorithm collision avoidance technology. Indeed, Veal argues that even the most impressive algorithms would not be able to satisfy the standard of a human. Thus, these ships would unlikely be considered to comply with Rule 2 if unsupervised, and so this would be a barrier to their introduction. Lastly, Rule 5 may prove to be a barrier with the requirement that every vessel shall at all times maintain a proper lookout by sight as well as by hearing to avoid collision. This again implies the exercise of human perception, something which fully autonomous MAS would not be able to satisfy. Remote-controlled MAS are more likely to be able to satisfy this requirement, but they would need cameras and sensors. Indeed, a merely GPS-tracked MAS would not suffice. Hence, this rule may prove to become yet another barrier to the introduction of MAS. To conclude, none of the regulations are likely to be a significant barrier for ships that are low level on the Lloyd's Register. However, the more autonomous ships will likely see the regulations being a significant barrier, particularly because whilst Section 3 and 4 of Article 94 of UNCLOS can be interpreted to include certain aspects of MAS, this is unlikely for fully autonomous ships. Similarly, with SOLAS, a review of terms such as ship and master is needed in the commercial context, and for MAS in a passenger context, a whole new set of rules will be needed.